Welcome everybody, my name is Sebastian Lührs. I'm member of the application support team at Jülich Supercomputing Center, and today I want to give you some overview about the JUBE benchmarking environment. I will start with some generic overview what's JUBE about, and will then give some insights on the key features of JUBE by presenting a generic example here within this talk. So first of all, what is JUBE and why can it help? So JUBE is a generic, lightweight, configurable environment to run, monitor, and analyze application execution in a systematic way. So it allows you to specify certain steps for your program, how it is executed, and allows to make the parameterization as easy as possible. So to rerun applications in a systematic way. So in contrast to a, let's say, script solution, it's a more generic approach. Of course, you can solve all the aspects of JUBE also with a Python, Perl, or Shell script, but JUBE tries to make the approach more generic to allow reusage of the most common tasks. Of course, its main aspects, and that's where the name comes from, and also how we started developing JUBE on our side, is to use it for benchmarking. But of course, it can also be used for many other aspects, like parameter studies, if you're interested in trying different parameter setups for your application, for just testing purposes, so to allow to rerun a specific setup, for example, in the continuous integration environment. Can be used for profiling, so to include some profiling tools which need some specific setup and to rerun this for the application. And finally, of course, also even for production scenarios. So just to have all the parameters in place and to make it easy to set up your parameterization. So why is it helpful? And here there is this nice XKCD where you can compare how often you need a certain task and how much time is saved when you would say make this task more efficient. And this is also the main idea of JUBE. So if you can try to automate a task, because maybe it is used for testing and you want to run this test once per week, and you save maybe some time instead of doing it manually by using JUBE for it, you will save a lot of time among several years. So that's the thing. If you want to rerun something multiple times, a lot of time can be saved by doing it in an automated way. However, on the other side, what JUBE is not. So first of all, JUBE isn't a profiling tool by itself. So JUBE allows to extract metrics which are generated by the application or maybe by other profiling tools, but it's not able to generate any metrics out of the sky. On this other side, JUBE is also not a building tool. So JUBE will follow the same process as you've done it manually. So of course you can compile applications within JUBE, you can run applications within JUBE, but you still have to follow the normal manual steps. So it's not a building tool like EasyBuild or Spec. And finally, JUBE is also no free lunch. So as you know, for any generic approach out there, it still has a steep learning curve. And if you check it here in this comic, so as often you have to start, or you think, okay, it's of course some learning in the beginning, so we have this steep learning curve in the beginning, but at some point automation takes over. However, that's the usual thing. If you start with something, at some point you will do more and adding more and more features to it, and the same approach will happen to your application benchmarks within JUBE. JUBE normally consists of, would say, 3 parts here. On the left side, that's the part which is provided by you when starting with JUBE. So first of all, of course, you need some application or some benchmark which you want to run. So this can be any application out there. It can be a generic benchmark, whatever you are interested in. The second part, and this is new, will be some JUBE configuration file. And during my talk, I will give you some overview how to create such a configuration file for JUBE. This file is necessary to tell JUBE how to run your application, what are the necessary parameters, and to specify the overall workflow. Once this is in place, you can go to your supercomputer in charge and run the execution. JUBE will take care of the parameterization and of the full workflow at all. And you can deploy something like this. So typically within JUBE you have some kind of tree structure where you have multiple steps depending on each other and having a parameterization within each step which allows to test multiple configurations at a time. The last part of a JUBE execution is the analysis. So here JUBE allows you to extract certain patterns of your result files and to create an overview showing the parameterization you selected in the beginning directly next to the results. So to have one single overview about your outcome. It's quite difficult, of course, to just give all the details of JUBE within 30 minutes. So I decided to show most of the, let's say, basic steps of integrating an application into JUBE on a basic example. And because besides working on the JUBE developer, I'm also highly involved in I/O benchmarking on our systems, I selected here IOR as a one example benchmark and how to show how to integrate an application into JUBE. So first of all, to start with a JUBE configuration file, it's quite easy. There is not too much overhead necessary because the nice thing of JUBE, you can nearly run everything which is already in place. So all the steps which you can run manually can also be directly integrated into JUBE. So, and the most basic approach for IOR will look like this. So first of all, you see, yes, JUBE uses XML. So it's maybe not the nicest thing for everybody, but the basic configuration format of JUBE is based on XML structure. The JUBE syntax is quite meaningful. So you have a benchmark where you specify the main out path, which is the result path. So here everything will take place. And you have certain steps. So here just one step which should execute our IOR benchmark. And within this step, we can run as many shell commands we like. So here we just call IOR without any parameterization. Of course, we expect in this case that IOR is somehow reachable and is sitting within the path variable. Once this setup is in place, we are already done with the JUBE integration for this very basic approach. And we can run JUBE by just saying JUBE run and our input file. And JUBE will tell us, okay, this is the first run. So each run will receive an individual ID. We see some information. So one step was executed here. But we do not see, would say, any outcome here because we didn't specify so far within JUBE how to treat the result files. So we just see what happens from the JUBE point of view. And if we want, we can dive into the directories to search for the output by ourselves. But of course, at a later step, we want to tell JUBE how to do this on its own. One first key aspect of JUBE is everything which you do within JUBE takes place within some kind of sandbox directory. So each run will create its unique ID and its unique directory structure. And within each run directory, you will find a structure which looks like this. So you have certain directories for each step. You have some generic configuration and information files. So you will find, for example, the configuration.xml, which was your original input dataset, and it allows you to rerun a certain benchmark later on. You will find some log files, and within each step, you will find a work directory which stores your standard out, your standard error, and all your necessary files of the run. So this is the most basic structure, and of course you can dive into the structure to search for certain outputs. This was quite a very simple approach, but now we want to take care of the parameterization, which is one of the key aspects of JUBE. So first of all, we have to tell JUBE what are the parameters we are interested in. And here JUBE allows any parameter you want. So there is no fixed set of parameters in place. So we specify a parameter set with a name. And within the set, we can specify as many parameters we like. For example, we can set a parameter for the block size to use in IOR, which we set to 100 megabyte, and another parameter for the transfer size. Here we use 3 different setups, 1, 10, and 100. So you see already, you can create something which we call template, where one parameter can have multiple values separated by colon. Also, the execute step slightly change. Here we now use our parameter set to tell JUBE, okay, we want to use these parameters within this step. And we change our shell command, so to use the parameters, we tell, okay, we want to use this block size and this transfer size. So we have 3 configurations to test, and an important point here, even this is a shell command, so even this looks like an environment variable, it's just a parameter within JUBE. So by default, JUBE will always check first if the variable you specified is a JUBE parameter, and if not, it will switch to the basic environment variables. We run it in the same way, and this time you see the first thing. Now we have 3 individual runs, because JUBE automatically will run the step execute for each configuration of the transfer size. So you have 3 individual runs on the system. Still no output, but now we were able at least to configure it within JUBE. And you see it's also quite easy to add more parameters if necessary. A parameter is quite flexible because it's the key aspect within JUBE, so it can be used at many different places. First of all, of course, you can use JUBE at different places within the configuration file. So you can use JUBE a parameter, for example, to enable or disable a specific do command. So it's similar to an if clause within a programming language. You can use a parameter inside other parameters. So JUBE allows you to do calculations or also more advanced approaches by using Python syntax here. For example, to tell JUBE to create list of parameters and so on. We saw we can use parameters within the shell commands, of course. We can also use parameters for text substitution. So you can tell JUBE to load a file and to replace parts of the file with some other content. So to substitute parts of a file, which is very helpful if you have an application which deals with configuration files instead of a long command line list. And finally, you can also export parameters to regular environment variables, which again is also helpful if you have an application which is mostly configured by environment variables here. So here parameters are very flexible to use. Now, with having the parameterization in place, the next step we want to do is to take care of the compile. So not only have one step for the execution, we now also want another step for the compilation. For this, we first need the source code, because before we expected IOR is somewhere sitting in the path variable and is directly available. However, when we do the compilation, we need the source files. And as you saw before, we are dealing with sandbox directories here. You can say, okay, the source is somewhere sitting in an absolute path on my file system. However, to make it portable to another system, it's always good to keep all the paths relative. So here we can tell JUBE first where are my source files and how to deal with the files. So in my case, I want to copy this directory, which is sitting next to my configuration file, into my sandbox structure. So I just say where to find the files and if I want to copy or maybe to link them. Then I need the compilation here. And the compilation is mostly basic for IOR. I have a bootstrap, a configure, and a make. Just again the remark, yeah, it's still XML, so you have to take care of some of the specific characters which are not allowed directly within XML. And I have my compilation step here. And finally, of course, I have to specify the execute step. Please wait until the compilation is done because it's a dependent step. So I have to tell this here. Finally, to use the executable which is generated in the compilation step, I can use a link. So this link is automatically available within the execute step and it is named with the name of the dependent step. So I can use this link, name compile, to access the compile directory and use the executable. So without even knowing the exact structure underneath, I know, okay, I'm in the execute step and I depend on the compile step, which I generated before, so I can go into this directory and use this executable. And now again, if we run it, we will now see not much difference from the output side, but now we see two steps here and the compilation is only run one time because it didn't use our IOR parameters here. The IOR parameters are just relevant for the execution, so we didn't use them within the compilation step. So the compilation is only executed one time. Of course, if we introduce another parameter set, it might be run multiple times. And then we have again the execution afterwards. This workflow creation is mainly depending on two aspects. First of all, there is a dependency-driven step structure, so very similar to make. And on the other side, there's a parameter-based expansion of steps. So what does that mean? If we have three steps here, a pre-process step, a compile step, and an execute step, and we say the pre-process and the compile are independent of each other, and the execute step depends on the pre-process and the compile step. So you can also depend on multiple steps. And we have three parameter sets. The first one just contains a constant value, which is 0. The second one, a parameter p1, which can be a or b. And the execute set contains just one parameter p2, which can be 1 or 2. So what does it mean for the preprocess, which just uses our preprocess set? It will be executed one time because it's a constant value, so it just has to be executed one time. For the compile step, where we use our compilation set which contains p1, it must be executed 2 times for a and b. And finally, the execute step will be executed 4 times because it depends on compile and preprocess. So we need at least one combination for each of them. And because we have 2 compile combinations, we already with p1 equals a and p1 equals b, we need at least 2 execute steps. But we also introduce a new parameter now by using the execute set here in this execute step, which means finally we end up with 4 combinations with p1 equals a and p2 equals 1 and so on. Of course, it's also possible to skip certain configurations if they make no sense, but by default you always will have this cross product of combinations within JUBE. With all these runs in place, we finally want to see something in the output. So now we want to tell JUBE how to treat the output of the application. And for this, we have to specify first what is our pattern set, so how to scan the output. And here we use regular expressions. So we have some regex magic by telling, okay, in this case, we want to search for the word write, followed by white space or multiple white spaces. And then there are also some predefined patterns within JUBE. We want to search for a floating point number. So the patterns, of course, as you know, regex can be quite complex depending on your setup, but in most or many cases, there are also quite easy setups by using a keyword and then the pattern you want to extract. Then we have a so-called analyzer, which tells JUBE which file we are interested in. So in this case, we want to scan the standard out of the execute step by using our pattern. And finally, we have the result, which tells JUBE how the result should be generated. We use our analyzer, so the analyzer output, and we create a table using 2 columns. So first we want to show the transfer size, so we can use parameters here. And we want to show the right bandwidth, so our patterns. So we can mix parameters and patterns within the output. To run this, we just add a -r to the run command to first run the benchmark and directly after show the result. You can also do this in 2 commands, but here we want to do this in a single command. So the benchmark is executed, it's analyzed, and finally we see the output. So we see the different transfer sizes, the parameters we used, and the different write bandwidths here on my local laptop for testing. So again, you can specify any regular expression, and if your output, your application output, for example, looks like this and you are interested in this number, you can do something like this by saying, okay, search for read, then some white spaces, and then there is some number, some floating point number. You can use groups, regex groups, to specify only a certain block, and this allows JUBE to exactly find this number in the output. But of course, this was just on a local system, but we are dealing with HPC systems here. So how to deal with job submission and asynchronous execution due to the HPC setups. So here the first important point is the JUBE kernel has no direct knowledge about HPC scheduling systems at all. Within the first version of JUBE, we did this, so we took care of all the different schedulers out there. However, this is quite a very difficult task because there are many options you have to take care of, and all these schedulers change over time, so you have to adapt your approach more often. And when dealing especially with applications, we saw having just a generic approach is not always the best case, because the users did a lot of fancy stuff within their job scripts, and it was quite difficult to adapt the generic approach of dealing, for example, with Slurm to take care of all these approaches. Maybe in the future we add, at least for some basic Slurm executions, also a direct Slurm interface, or also for other schedulers, but for now there is no direct scheduling interface within JUBE. However, we want to deal with it, so what do we do? So in the end we have everything in place, because we can use parameters and we can use templates, so to replace parts within a file. So what we provide are job template files for Slurm and for other schedulers, and we can use our substitution system to replace parts of these templates with configurable parameters. The nice thing of this, you can easily extend it by yourself. If you use a complete different scheduling system, or if you want to use a specific template file because you need multiple sruns or whatever within the execution, you can easily adapt this within the template. The other aspect, which was more important from the JUBE point of view, to support asynchronous command execution, because once the job is submitted, JUBE has to wait somehow until the job ends. And we didn't want the blocking behavior. So the problem of blocking behavior is always if something goes wrong on the login node or somehow your shell crashes, you have to restart your whole thing or you end up in some corrupt way. So what we decided on was to tell you can run the initial JUBE setup and the jobs will be submitted, and then JUBE will come back, or you will come back to your shell command prompt. You can do anything else, and at some point, if you are interested to check the runs, you can run the JUBE continue command, which will check if some specific marker files you can set within your job were generated, and if this is the case, JUBE will continue in processing. How does it look like for our small example here? So in my case, I will specify some system parameters, so the number of nodes. So maybe I want to use I want to test 3 different setups here, 1 node, 2 nodes, and 4 nodes. How many tasks per nodes I want to use, the executable I want to use, and the arguments, so everything which I specified before directly in the execute step. And in this case, I use a predefined platform.xml file where I store all, would say, default configuration for our system here. We also ship JUBE with a bunch of those platform files for, would say, most common scheduling systems, but of course you can also create those by yourself. And there I can store all the defaults, how the number of tasks is calculated, and so on. There is still not a fixed, would say, node parameter directly in JUBE, but of course I can create it here. I can overwrite the defaults where necessary. And I also use, for example, here some other default sets, for example, the job file templates, which I created before. So I do not have to recreate them all the time. If I'm fine with my templates and I'm store them on the system in a central place, I can reuse them all the time. And the most important part will be here to specify this done file, which tells JUBE, please wait until this file is generated by the job script. For example, in the end of the job script, there can be a touch, whatever, and to tell JUBE here, please wait until this file is generated before continuing. And of course, we now do not scan the standard out anymore. We are now interested in the job output, so we have to specify the name of the output file. Finally, the run looks like this. So on the top, you see the jobs were now queued. They are not executed so far, so they are running, or at least they are queued in the system, and at some point they will run on the cluster. And you see also we now have 9 jobs in total. Why 9? So we still have the setup for the IOR by using 1, 10, or 100 megabyte for the transfer size, but we now also introduced another parameter for the number of nodes, 1, 2, and 4. And again, we use the cross product here. We end up with 9 jobs in total. If we now wait for some time, the jobs are executed on the machine, and we run the JUBE continue command, also adding the -r to give us the result overview. We will see now, okay, for all the different setups, number of nodes, and the different transfer sizes, we receive our write bandwidth. So for typical execution, it will look like this. You have your steps. A step can submit a job, which then somewhere ends up in the queuing system. You can run a JUBE continue, which will check for the done file. If this is not created, JUBE continue will directly return, and you can do something else. You can do this multiple times, and at some point the job is done. It will create this done file, and the next JUBE continue you will call will see it and can continue processing. So very simple mechanic to just take care of this asynchronous approach. We saw already a bunch of different command lines. So the most important command line calls are the JUBE run and the JUBE continue. You can also run the analyze part just separated from all the other parts by using JUBE analyze. And if you are just interested in reopening a result, there is a JUBE result command as well. Because you already see there are a bunch of aspects necessary to deal with JUBE applications, there is an online documentation available on our sites with a nice tutorial which gives you the key aspect, or which shows the key aspects of JUBE, and also an advanced tutorial which shows more advanced aspects and also some features which were added over time to JUBE itself. There is an info mode where you can ask JUBE to give an overview about your benchmark runs. There is a command line accessible glossary, so you can check for certain keywords directly on the command line. You do not have to open the PDF all the time. You can check within the logs. There is a debug run mode, which is very helpful. It will just run the JUBE structure, but will not execute any command. So this is very helpful to just check if your JUBE setup is correct. And finally, there is also a verbose mode, which gives you the output on the fly, for example, so you can see what's happening within my benchmark. How to use JUBE then in a, would say, larger setup. Of course, you can use it for certain benchmark, but we also plan at JSC to use it in our all-day testing structure. So we have already a quite large benchmark application suite because we use it, for example, for procurements of our systems. And what we plan to do is now to use all these benchmarks. We have them currently within our local GitLab, connected to a GitLab runner to use a continuous integration schedule to run this whole suite, for example, once per week or at least after each maintenance, to check how the overall benchmark setups or the output of the benchmarks change over time, because we have a lot of software updates, we have a lot of hardware updates, and to verify the stability of the system. And this approach, of course, is quite easy to realize with JUBE. Once you have the application in place, you have this basic or this general approach which allows you to run the setup on multiple systems, and then in our case to feedback the results into a central GitLab repository. JUBE itself, you can download it directly on our website. You will find the tutorials and also a lot of documentation. There are not many dependencies, so in the end we support so far just Linux, and it's based on Python. You just need a default Python 3, so there is no additional dependency. We want to have it as lightweight as possible. Of course, if you still have a Python 2 on your system, this is also fine for JUBE. So you can run it within Python 2, at least starting with 2.6, but also with Python 3. And of course, feel free to contact us if you see any problem or if you have a feature request from your site. Before ending my presentation, I just want to give a small example of dealing with a JUBE run. So here I'm on one of our systems, and I'm having here the IOR benchmark, which I showed before, and it's even extended with much more features of JUBE. So for example, I can store different configurations to reuse them over time. I can use so-called tagging to specify parts of the file which I do not want to execute every time. For example, to skip the compilation step or skip the download step of source files. There are a bunch of parameters which are executed or which are calculated. For example, I can use Python or shell parameters which are generated on the fly. And also on the result creation parts, I can use many different aspects which I do not or cannot show here within this small talk. But of course, I want to run this. So I just tell JUBE to run it. And I say, OK, please run it in verbose mode to see it a little bit. And I want to skip the download in my case and using the first setup which I configured. So it will then start the JUBE execution. And then you already see the compilation takes place here. So this is because of the verbose mode. In default, you will see no output here. And the execution or the compilation is running on the system. So this takes a few seconds. Of course, compilation is always the thing. If it is not necessary to recompile your application every time, it is not necessary to integrate this within the benchmark. But of course, if you are, for example, interested in a parameter study of different compilation options, it's quite helpful to also integrate this step into your benchmark setup. And now we are already done. So you see JUBE returned to the command prompt. The jobs were executed to the cluster. in this case, because it's a I/O benchmark, I submitted them using a dependency to only run one job at a time, to not influence myself while running this benchmark. This will take some while, but of course I prepared already some output here, so we can use the result command on my benchmarks directory and selecting a specific run. And to see it, here we have the output, now also with some more parameters. So we also have the read bandwidth next to the write bandwidth, and also the other output which is generated by IOR. Okay, so finally, this was everything I wanted to show today in this very short overview about JUBE. And final slide, so one last thing, because I mentioned it already that XML is maybe not the nicest thing for all of you. You can also wait for the next JUBE release, which will be available in the next 1 or 2 weeks, which then will also have support for YAML as well. So we also support then a second input format, which is YAML based. XML is still possible, but YAML of course is sometimes a little bit easier to read and write, so this will be available. Thanks for your attention, and of course then I'm open for questions as well.